Okay, we're back on page 3 of the notes for Algebra 2, sections 4, 5, and 4, 6. In this little part, we're starting the process of learning about identity matrices, and also about multiplicative inverses of matrices. Now, the first one is a very easy concept. What you have here is a specific setup on a matrix, and we're going to see later what happens when you multiply by the identity matrix. It's called the multiplicative identity matrix, but most of the time we just say the identity matrix, and they always use the capital letter I if it's the identity matrix. Now you'll notice that these two examples here and others look like it. First of all, they're square matrices, 2 rows and 2 columns, or 3 rows and 3 columns, but you could have an identity matrix that has 4 rows and 4 columns, or so on. So we would call one with 5 rows and 5 columns I5. Now in the end, since you're going to be looking right at the matrix, and we can assume that you know how to count the number of rows and columns, the little subscript gets left off. So in practice, we usually just write a capital I and let the reader see for themselves whether it's a 2 by 2 matrix or a 3 by 3 matrix. Now, a couple of characteristics of this. First of all, it's filled with ones and zeros, but the ones follow a very specific pattern. They're always on the diagonal that goes from row 1, column 1 down to the right. So you've got this main diagonal, it's called, from the top left corner down to the bottom right corner. That is filled with ones, and everywhere else is filled with zeros. And this is what the identity matrix always looks like. So if you got a little 2 by 2, it's 1, 0, 0, 1, and got ones on the main diagonal. 3 by 3 is a little more complicated, but if you think of filling the main diagonal with ones and everywhere else gets zeros, then you can easily tell it's an identity matrix. And it would always be labeled I, or perhaps I with a subscript that would correspond with the number of rows and columns. Now, there is another concept that we're going to learn, and that's that when you multiply two matrices together and you end up with I as an answer, then the two matrices are said to be inverse matrices, opposites of each other. So when you multiply two matrices together and you end up with I, then you say of those two matrices, oh, those matrices were inverses of each other. Now, to kind of put this on a familiar ground, this is similar to saying that when you multiply reciprocals, you get 1. So if you have 3/4 and you multiply by 4/3, you'll get 1. You'll get 12 over 12, which is really just a 1. And we call these reciprocals because they multiply to give 1. Well, the same thing happens in this context. If you have a matrix A and a matrix B and you end up with I, then you say that A and B were inverses of each other. We don't use the word reciprocal, but it's a similar concept, okay? So here we go. We're supposed to show that these two matrices, A and B, are inverses of each other. So we're going to multiply them together. And we learned this in the last section. So I'll try and remind you how to do it. A is a 2 by 2 matrix, and B is also a 2 by 2 matrix. And since the middle numbers match, you know that you can do this, and then the outside numbers tells you how many rows and columns. So we're going to use these rows from the first matrix, and we're going to multiply it by the columns of the second matrix. Okay, so here's how you set this up. First of all, let me get rid of some of this highlighting here. You first of all divide the rows, and I'm dividing the rows in my answer down here. And in the other one, you divide the columns, and in your answer also. So now we have 4 corners that we have to fill in. This corner here is the top left-hand side of my answer matrix. So I'm going to use the top row on the left-hand side. 2 times negative 2 would be negative 4. Then you move over to the next pair, which is 1, and down to 5. So 1 times 5. So you do the first 2 and then move to the right and move down on the other one. So that would be plus 5. Then I'm going to switch to this corner, which is in the top right. So once again, I'm going to be using these numbers and these numbers. And I'm going to go 2 times 2 would be 4. And then 1 times negative 4 is negative 4. Okay, and then we're going to switch gears now. We're going to be in the bottom, down here, in the bottom left of our answer matrix. So we're going to use this bottom row here. And left would be this column. So you start by going 2.5 times negative 2 is negative 5. And then 1 times 5 would be plus 5. And next we're going to do the bottom row, and we're going to switch to the, sorry about that. We're going to switch to the right-hand column because this is the bottom right. All right, so 2.5 times 2 would be 5. And 1 times negative 4 is negative 4. And if you calculate all these corners, you get 1, 0, 0. Looks like I didn't cross that 5. 1. And this is the identity matrix. And so, yes, A and B are inverses. Now, the usual thing to do when you know they're inverses is not to name them with different letters, but to write A for the first one and A inverse, and it's a little negative 1 power there, A inverse. And when you multiply A, instead of B, you write this. And then you write I for the result. And honestly, if you didn't get I for the result, you wouldn't use this inverse symbol here. The inverse symbol is shown in the notes right there. A inverse. Okay, let's multiply this next one and see what it gives us. I'm going to go a little quicker this time. We're going to have an answer matrix here where it's divided into rows, 2 rows, and the other one's divided into 2 columns. So then we have negative across the top row in the left-hand column, or in this row and column here, you get 16 minus 15. 16 minus 15, and that will give 1. So far, so good. Okay, the next one here is in the top right corner, so you got to use the top, but the right-hand column. So negative 10 plus 10. And it's looking like the identity matrix here, so we may be saying that A and B are inverses again, but let's keep going. We're in the bottom left corner, so you have to use that bottom row on this left side. So the first 2 would be 24, and the last 2 are negative 24. And then we're in the bottom right, so we're going to use the bottom row in the right-hand column. The first pair gives negative 15. You always start on the top of the row and the left of the column. The next one gives plus 16. So here's the final results. And since that's I, yes, A and B are inverses. So we could call this matrix A inverse, or we could go the other way and call this matrix B inverse. Okay, so eventually on the next pages, we're going to learn how to find the inverse. Okay, so finding the determinant of a square matrix of 3 by 3 You guys can leave these problems off right now. I'll show you how to do these on a calculator, but finding an inverse of a 3 by 3. Oh, no, we're supposed to just show that these are inverses. I apologize. Here we go. Sorry, this is the next page, and it'll be the next video.